Hey QED coders, this is Michael. We are going to be talking about doing some authorization with Janaga today. So in the past we've done authentication, and we have then identified the user thus authenticated inside of Janaga. Those are two separate things because authentication happened by some identity provider, Twitter in our example, and identity was a fact inside of the Janaga data model that represented the user. And then we could hang things off of that fact. One of those things being the user's name, which we got from their profile. So go back to those previous videos to see all those things in action. Today, we're going to be doing authorization. So, this being Groundhog coding, we need to start from scratch. Every single day, we are building a brand new application, and at the end of the session, we throw away everything except for what we've learned. Learnings we get to carry forward and put into brand new documents and brand new starter kits and update existing starter kits so that we can carry that knowledge forward and use it for other applications. So let's begin by going to the Janaga website, and as always, we grab a starter kit. I'm going to continue with the TypeScript with React starter kit because I have not yet had a chance to update the JavaScript starter kits. Let's go to our command line and export that starter kit to Yaka. Now open up Visual Studio Code in that location. And so here we are, C Project Yaka. And I'm going to do my npm CI, which is the fast version of install. Then in another window, I need to create my Yaka database. So I'm going to use psql. The host is localhost. And the user is Postgres. The database I'm going to connect to is Postgres. And then once I'm connected to that database, I will do create database Yaka. There we go. The Yaka database is created. Okay. Let us Control D to get out of that and see if we have node modules Janaga. We do, and there's our setup script. Okay, so we've gotten that far. So we will psql host localhost user Postgres, and the database now is Yaka. We will run the file node modules Janaga setup.sql. And it's set up our Janaga database. For right now, I want to go ahead and modify the application so that it uses the proper database. So here on the server side, we have Janaga config, and this is currently using my application. Let me change that to Yaka. So that is the Yaka database. And right here, we have configure authorization. I'm going to turn that on in a little bit, but first let's go ahead and run this and make sure that everything is working. So I will go back to the first command line, and we will do an npm run start. And I haven't built anything, so of course that failed. Npm, let's do an npm run dev. I think that this fails unless you do a build for the first time. Yeah, it does. Yeah. So npm run build is really the first, after npm install, the first thing that you should do. And all these things are in the README if I were to actually take a look at it. And so that is going to compile the server-side and the client-side code using Webpack and TypeScript. Certainly does take its sweet time. There we go. Now npm run dev that will set up a watcher so that it will watch for any changes that I make to the files, recompile, restart node if necessary, and this gives us a good development experience. So we now have something listening at localhost 8080. Let's control click on that, which opens up a browser tab, letting me sign in with Twitter. So I go to Twitter. I've already given it authorization for this application, and so I'm redirected. I'm visitor number 1. If I refresh, it counts up the visitors. Okay, so we're good. We have our starting point where we're doing Twitter authentication and we're doing identity with Janaga. So to remind you, the identity takes place is in index tsx. And here is where we do our j.login. So this is the identity. So you do a login, you're going to get back a user fact, which we will call user, and you will get back a profile. So this code we went over, it sets the user's name based on the profile so that we can then use that inside of the application, inside of the model. So we have authenticated and we have identified. Now we need to authorize. So only certain people should be able to do certain things. Let's start building our Yaka model and see who's supposed to be able to do what. In the shared model, we've got our users. So we just talked about username. And we've got our visits. We don't want visits anymore. We'll get rid of that in just a second. But what we really want are channel.ts. So here we will import Janaga as J from Janaga. So now we can start writing some Janaga model code here. So one of them is going to be a class that we call channel. And a channel has a type with a capital T that we call Yaka channel. And then type with a lowercase t is going to be channel.type. So whenever I create a brand new channel, that's the type that it gets. What else does it get when I create a brand new channel? Well, we need to provide the name. That's a string. And there we go. So with that, we can set up a brand new channel. Now I want to be able to put messages in the channel, so let's create a message class. Its type is going to be Yaka message. Type, if I could type, is message.type. And when I construct one of these, I construct a message in a channel. So it's going to be channel. And the message is from a user. So the sender is a user. And we will import that from user. The message will also have a timestamp. So created at date. And we will also have the text, which is a string. And just as a matter of convention, I like to have the created at date be the last thing. So that describes a message. I can create a message in the channel sent by a user with some text created at a certain time. So in order to be able to help with seeing all the messages in a channel, I will have a static template function that is messages in this channel. Actually, I like to have this on the other side. It reads better, and message already knows about channel. Notice, channel doesn't know about message. You know about your predecessors. You don't necessarily know about your successors. So if you keep all of the arrows pointing up, things work out better. So in channel C, this is going to match a message. So I'll use that little typecast right there, where the type is message.type, and the channel is C. So you can see there's a few other things, created at, sender, text. I'm not matching based on those. So those can be anything, but as long as its type is message type and its channel is C, that parameter there, this template function will match. So there's all the messages in a channel. All right. Now I can use that template function inside of my user interface. So let's create that, shall we? Go back to the client. Here are my components. I've got my app. So I don't want this visit counter. I do want the user. The users are valuable. But I also want a channel. Let's say instead of a visit counter, we will have a channel view component, and it's going to have user equals user, and channel equals, and we will specify a channel. How about new channel, which I can bring in. It's not helping me to bring that in because that's out here in shared. So let me do an import statement from shared model channel. I want to import channel. So here's my new channel, and I have to specify the name, general. Okay, so I need to write a channel view. Let's go ahead and create one. I'm going to want to import channel view from channel view, like so. And cannot find it because it doesn't yet exist. Can I control click and create it, please? Wow, I thought I could control click to create it if it wasn't found. Oh well. All right. Channel view.ts. And now we are going to export. We're going to have the channel view extend or extends react.component which I need you to import. Can you tell me an import, please? It's not going to do any import for me. All right, import from React. Yeah, import star as React from React. Okay, there we go. So my channel view. Well, I made this a class. That's because I wanted a constructor. So here's my constructor. Props. What are the props? Well, the props are going to be the channel props type. Bunch of stuff. Well, we already know what we put on it. We put on a user. There's my user. Hey, found the auto import. And we put a channel in there. There's my channel. Okay, there's my type. So that means here I can say P, the props type, is channel props. And S, the state type, channel state. So that we will define in a little bit. But in come the props. Super props. Super props. Oh, we have to say this constructor takes the channel props. There we go. Now I've got my props. I can set up some state, which we will see in just a little bit. And we need to render. And as we do so, we are going to start to access some state and see what that state needs to be. So, not that, we don't need that. We're going to have an unordered list. TS, I didn't tell it it's a TSX. Hold on a minute. Rename TSX. Now you can do the ULs. Great, thank you. All right. And then within these ULs, I'm going to create a bunch of list items. And I'm going to create them based on messages or message view models. Because as we learned the last time, or one of these times, it's best to have view models inside of your state rather than the actual facts. So we're going to have message view model array. That's going to be my messages. And so we need to define message view model. Type, I think I need to export it. Message view model. Is it a class? Or is it just a type? Let's start with a type. I don't think it's a class. The message fact itself is this guy. So now we've imported that from the channel. Good. We're going to presumably have some array of these things. And those things will be in this.state.messages. And we can now map. We'll just call it VM because we know it's the view model. To some thing. Right? In fact, it's going to be an LI. So inside of that LI, we've got things like the text. So span vm.message inside of brackets because we're going back into JavaScript here. vm.message. And there it is, text. Very good. So I can put the message text in there. And this is also where I can do things like the sender. So I need the sender's name, and we don't have that directly as a predecessor off of the message. That's something we have to write an additional query for. So name sender shall be a string. And we'll say vm.sender right there. Okay. So let's go ahead and set up that state. This.state is equal to messages is an empty array. And that's how we're going to render it. Let's go ahead and say down here, components did mount. And this is where we want to set up the subscriptions. Not subscriptions, that's something different. We want to set up the watches. So I will say const w equals j. Oh, where's j? Well, then we need to auto import it from Janaga config. Dot watch. Did you get it from the right place? No, you did not. Out. Janaga config. Here we go. j.watch. That looks better. So what's my starting point? I'm going to watch the channel that's passed in. So this.props.channel. That's my starting point. And now I'm going to watch for messages in the channel. j.for message dot in channel. There we go. We are watching for those messages. Once we see one, this is what happens. We have the message M. And I'll spell that out, message. And then I want to call this dot add message. There we go. And then when the message is removed, which it can't be by this particular query, but as we saw before, we need the removed in order to properly set up these view models. I might just go ahead and fix that in the API. But when you remove it, just remove message. Okay. And that's the view model that's coming back. So we set up that watch. Now, what is add message? Let's go ahead and do that. Private add message. There's my message coming in. So I need to do a this.set state. That reminds me, yes, there was a little thing that we ended up having to do that really kind of bugged me. And it probably bugged you too. We're going to have to do it again, but this is my reminder that I need to fix this issue. We should be able to get the hash of a fact from Janaga. It should expose that through the API. And you could use that string as a key. And that is going to make this pattern a lot easier. But for right now, we will have the math.random. We'll have this little hack. Okay, when the message is added, we're just going to come up with a random number, and that's going to be the key. Sure. Okay. And then we're going to set up the view model. So that's going to be a, in fact, I'm going to explicitly give that a type, a message view model. And so that means that we need to provide the message. That's the parameter that's coming in. And the sender is going to be a string, which we will start as the empty string. There we go. That way we can return the view model. I also want the view model to have the ID. So let's go ahead and add that to the tab. So in the future, this will be string, and this will not be random number. It will be compute hash message. Nice and simple. So we've got the view model. Now I want to do set state. So let's do our this.state spread operator. So we're spreading all of those things that's in the state except for our messages, which is now going to be an array. And that array is going to be the spread of all this.state.messages with the addition of this particular view model at the end. So that's my new state. My new state is the old state with a messages array that's the old messages array and this particular view model. So the new state has this view model in that array. And we're returning the view model. Remove message. Let's just say private remove message. And we can see here, what does VM have to be? It has to be a message view model. You might be wondering, how could it ever be called? You know what? Let's go ahead and make it so that it could be called. Let's go ahead and give the user the ability to redact a message. I like this plan. I like this plan because it will lead into the authenticate or the authorization that we've got coming up. So what does it mean to remove a message? Well, we say this.set state. And so we have to provide state. Well, let's spread over this.state, except for messages, which is going to be this.state.messages.filter. So we only want those messages, or view models really, where vm.id is not equal to, well, I'm calling this VM here. Let's call this m. m.id is not equal to vm.id. What? What does that mean? Oh, okay. What that means is that we're going to take all the messages, and those that have a different ID than the one that we're trying to remove, they get to stay. Anything that has the same ID will not match that filter, and so it will not be returned from this new array. So we compose a brand new state with this new array that does not contain the message that was just removed, and this is how we remove a message using immutable data types, as is the React way. And I like it. It's pretty sweet. All right. Now, why would remove message ever be called? See, you've just run this message in channel template function, and if you get a message in the channel, it's always going to be in the channel. Let's suppose, however, that we've got another class called message redact. So static type equals yaka message dot redact. Redacted. I'm going to call it redacted. Message redacted. So the type is going to be message redacted dot type, and the constructor that we must provide will be which message do we want to redact. Okay, so that is our fact. The fact, this message is redacted. That is the fact. How does that help us? Well, what I can do is I can say that I've got a template function that is message is not redacted. What does this mean? It means that not exists a message redacted where the type is message redacted dot type, and the message is m. You see? Okay, I think I'm starting to see this. So message is not redacted is a condition. It's a template function, just like the other kinds of template functions that we saw before, but rather than match, we're doing not exists. And that gives us back a condition that is only true if there does not exist a message redacted for that message. Once it exists, then that condition becomes false. So I only want the messages such that message is redacted, message is not redacted. That doesn't read very well, does it? That doesn't read well at all. Now that we already know about this, let's go ahead and move it up. Then I can say there we go. Message is not redacted. That reads better. So, a message is not redacted if there does not exist a message redacted for that message. The messages in the channel are all of the messages, so we're going to match all of the messages where channel is that channel, such that the message is not redacted. So, as soon as you redact a message, it no longer is returned from this in-channel query. That means that right here, when we set up this watch this channel for messages in channel. As soon as you redact the message, it's going to call remove message because it's no longer true. That's how that's going to get called. Okay. Now I've got this W here. This is a watch of message and message view model. So let's create the watch. And that comes from Janaga. And so I can just say this.watch is equal to that. And then when component will unmount, we will just say this.watch.stop. Okay, then you stop watching the channel. Yeah, now we want to be able to add something to the channel. So that means this has to be more than a list. This has to be a list and a form. Now let's go ahead and put little brackets around it. So then I can say I've got a form, and this has an input of type text. And there's my little input form. Very good. And then the value is going to be this.state new message. Where's new message? Let's put it into the state. New message string. Very good. Now I need to initialize it. New message is an empty string. Very good. And then, well, I do want to have a label. Just call it a message. And then here is my input type equals submit. Value is send. So send the message. Now on not on click of the submit, on submit. So on submit of the form, we're going to take an event. And we're going to send message. E dot prevent defaults. That's what I need to do here. Okay. Let's send this message. To send a message, I shall do something asynchronously. So I shall j.fact. I'm going to create a new message. And the channel shall be this.props.channel. The sender shall be this.props.user. And the text shall be this.state.newMessage. And created at shall be new date. So there's my fact. There's the message. And then once I have the message, I can do this.set state. And I want to do everything that's in this.state except new message shall be back to an empty string. Now, as the user is typing, this input right here is going to get changes. So on change, this is going to be a brand new event coming in, and then I will say this dot set new message to e dot target dot value. And that's what I was thinking of up here. So e target value, that's coming in as a string. So let's set the set new message string. In fact, let's go ahead and call it new message. That way I can just do this.set state to everything that's in this.state and new message, just as the user typed it. So that gets set to the state. Poppity poppity pop 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 as they're typing, and then they hit send, and then it sends the message, sets it back to empty after we have confirmation that it was sent. And in the meantime, it prevents the default so it doesn't refresh the page. So all that, sending the message, querying for the messages, looks like that should work. Looks like we also have some defects here. Channel view TS. Looks like things got messed up when I did the rename. I should just do an npm run build, see if all that works. Okay, we've got a clean build. Npm run dev. So that starts up the node server, and now I can refresh. Sign in with Twitter. Sends me over to Twitter. Here's your token. Sends me back. Now I'm back. Here's a message. And this is the first message. Send. It didn't clear it away because there was a problem. There was a problem right here. Unknown token. Interesting. There's an unknown token in the JSON. How did that happen? That's really weird. Huh. Okay. Looks like this is another debugging episode of Groundhog coding. You know what? The debugging episodes are kind of my favorites. So let's go to sources. And we will see inside a Webpack, here's dot, here is source, client, and components. And now here is our channel view. We come all the way down here to send message. All right, the first message, send. So here is message. That looks like it should work just fine. So then I do j.fact. So that happens asynchronously. When it's done, we've got, there's the new message. The first message popped in there. And then if I hit F8 now, clears it out. Very interesting. The second message. I'm going to have to go back and watch the film and see what it was that I did the first time that caused it such difficulty. At any rate, here we are. We have the core of our Yaka app. Now we want to be able to display the user, yada yada yada. We saw that kind of thing before, but let's go through it again real quick. And that would be right here when the component did mount. We want to extend this watch. We want to further watch for the user's name. So that means that I'm going to want to watch for the message.sender, and I can do that with a template function, which I will call sender. This doesn't conflict with the sender that's here because this is an instance field, and this is a static field function. Those things don't conflict with one another. So the sender for a particular message is just going to j.match m.sender. But in order to make sure that I don't crash and burn before I do this, I say any m has sender. That way m.sender is not going to crash. Because in reality, this m that's coming in is just a proxy. It's not a real message. So now we've got sender. I can use that right here. This.watch. Watch some more. So I've started by watching for messages, so I can see here's a preposition that starts with message and continues from there. So j.for message.sender. So that's my my sender. So now you can see I've got a preposition that starts with a message and then gives me back a user. So I can continue forward. Then user name dot for user. We didn't see that one this time, but here it is. Here's the template function that gives me the usernames for the user. And here we see the use of such that to give me back the current username. So go back to the previous episode to see how all that works, but that's very similar to the redact pattern that we just did. So now I've got the usernames. Once I have the usernames, I will take this result. In fact, let's say user name. And what is that? That is my, message view model. Haha, I need two things. I've got the VM and I've got the username. There we go. So the view model, that's the message view model. Username is the username. Once I've got those two things, I can say this dot set username in this VM to this username dot value. In fact, let's go ahead and call it what it is. It's sender. Looks good. Looks good. We just need to set up set sender. So we've got add message, we've got remove message. Well, let's put it right here. Private set sender in this message view model. Sender is a string. Why is it a string? Well, because right here, when I said set sender, I grabbed the user's name value, and that's a string. So that way, sender's coming in as a string, and I can say this dot state set state. Set state. Go through my whole spread pattern, this dot state, and then the messages. So that's going to be this dot messages dot map. I used this M here. That's not the one I'm thinking of. This one right here. This M is what I used as the parameter. Let's go ahead and use that just to be consistent. Not sure if I like that, because that's a view model, and this is a view model. But here, I'm doing the mapping. So if m.id is equal to vm.id, then I want the message spread out with sender as the text. Otherwise, I just want the message. So does that make sense? It's a little bit convoluted what it's doing there, but we are taking the array of messages and then we're mapping. So for each message in that array, we're either returning that message itself unchanged, or if its ID happens to be the ID of the thing that's coming in, then we're saying, all right, everything that's in there except we want to go ahead and set the sender of that view model. So this dot messages, well, this has to be this dot state dot messages. So that's my message view models. That means this is a message view model, and a message view model has an ID, and it also has a sender. We can see right here, sender. That's a string. Says so right there. So that just replaces the sender string, replaces in an immutable way the sender string in that message. So we set the state. And this means that now when I refresh the page, I've got my name. So we know the name of the person who sent the message. So all this is great. All this is fantastic. And all of this is a review. Now I want to redact the message. So let's go ahead and redact the message. So right here, when I've got my messages that I'm showing in my list, let's also show an anchor, redact, and then href, go ahead and set that to pound. On click, that's going to be a little lambda, so we take in our e. I want to make sure that I say e dot prevent default. So I've got all that going on. But in addition, this needs to redact the message. So we should say this.redact message. So which message is it that we are redacting? View model. That's the one that contains the message. Which reminds me, by the way, we should have a key right here. And this is going to be the viewModel.id, which is right now a number, should be a hash. It will be in later versions. Redact a message. How am I going to redact a message? Redact message. And we've got a message view model coming in here. I'm going to redact a message. I do j.fact. Right? I need to create a fact. The fact will be a new message redacted. Which message am I going to redact? ViewModel.message. Et voila. I've created a message redacted fact. So great, yeah, you created a message redacted fact. What's the big deal? All right, redact message does not exist on channel view. Do you mean react message? Well, no, I actually meant redact message. So, oops, I don't need to hit build, I just need to save. So, thus saved, refresh, I've got my redact links. I hit the redact link, boom, message gone. Message redacted. Oh, that one's gone too. Oh noes. Oh, the first one's gone. Haha, this is fun. This is fun. And I refresh, and the redacted messages don't show up again. So what just happened? What just happened? I created a message redacted fact. That's all I had to do. When I created that fact, that meant that this condition here, the message is not redacted, now became false because there exists a message redacted fact for that message. Which means that now in channel no longer returns those redacted messages. They are still there. Oh, see, they're still there. It's just this clause causes them not to appear. Magic. All right. So that is the magic of Jnaga and the such that clause and message redaction and all that fun stuff, but that's not what we're here to talk about. We are here to talk about authorization. I want to authorize a user to do these things. Not just any user should be able to redact just any other user's messages. No. No. Don't want to allow that. That would be bad. If we could allow that, we could do something like this. Let's go into the evil universe and sign in with Twitter. Now I'm going to sign in with my scrap room. There's Jenny. Logging into the application. All right. And now she redacts my message. What? That's just wrong. That's just wrong. She should not be able to redact my message. No. No, 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 no. Let us disallow that. Okay. The way that we're going to disallow that is we're going to set up authorization rules. So here is Jnaga config authorization. Let's configure authorization. What is this? This is a function that takes authorization rules. We can set up a whole bunch of things. In fact, I don't even need these parentheses anymore. Those are just left over from a day when I didn't quite understand semicolon insertion. So, A gives us these different options here. We can say any. I want to return any. I want to authorize any user. All right, so user.type. If you see any fact of that type, it's authorized. That's great. I want to authorize the type user.name or username.type with the preposition. So this preposition gives you back which users are authorized to create that fact. Who is authorized to set the user's name? J.for username.user. I must not have username imported. So username.user. That is a template function that matches that username's user. So that particular user that has, that really should say Yaka now. I forgot to change that part, but that's okay. So that particular user is the only user that should be able to set the username. Okay, that's useful. There's no. Nobody should be able to create facts of type visit. Just making stuff up. Nobody is going to try to create any visits in this one, but let's just say, nope, we're not going to allow anybody to create visits. Then we've got with. With is extremely useful. This lets me take another function and apply it here. So I can decompose my model into lots of different files, and each one can have its own authorization. So let's go ahead and define some authorization rules for the channel. And so right here, export function authorize channel. And this takes an authorization rules, and it returns an authorization rules, which I can then do stuff to. So I'm going to authorize the type message.type, and this will be j.for message sender. So that means only the sender can create a message. So you can only create a message if sender is yourself. What does that actually mean? What that means is this rule prevents people from spoofing other people. I cannot send a message and make it look like it came from you. If I send a message, it has to be sender is me. I'm the only one who can do that. So that's the rule there. Now for the message redacted type. Who can send a message redacted? J.for message redacted dot message. Don't have that yet, but here we are. Static message for message redacted. This matches mr.message, which means that I have to say any mr has message. So, who can send a message redacted? Well, just the message. Wait, that's not right. Not just the message. The message is sender. So, and then message.sender. So we chain those queries together. And so the only person who can send a message redacted is the sender of the original message. That's the rule. Okay. Now let's go back to config here. And I want to bring these rules in. So authorize channel, import that. It's not importing. And let's save. Still not importing. All right, let's be explicit about it then. Import from /. Oh, I'm here. Shared model channel authorize channel. There we go. J isn't defined. And that's because we're on the server, and so we need to do Jnaga as J. There we go. Now J is defined. And good. So it has restarted the server because all of these authorization rules are run on the server. We've put some of the authorization rules inside of the shared library because that's a really great place to define the model. But the client never actually runs the authorization rules, only the server does. Here's a point for my future self. What if the client were able to run the authorization rules just so that you can disable things like the redact button? So you remove the redact button if you, logged in user, are not authorized to do it. And that could be a client-side thing. That could be useful. All right, so now we have, there's Jenny, there's me. I say, hi, Jenny. Send. It's not sending. Ha! There's that unexpected token thing again. Okay, it's parsing the response. All right, so what's coming back in the response? Save. Nothing comes back in the response. Login. Oh, interesting. Okay. When it restarted the server, it lost the session, and the browser still has the session token, and so the browser is trying to post something with that session. The server says, I don't know what the session is. You're going to have to log in. If I refresh the page, I get my login prompt. Okay, If I added a session store, then that would not be a problem. So I really should do that. So, hi, Jenny. Boom. And so if I refresh, I have to sign in with Twitter. Redirects. There's Michael saying, hi, Jenny. And Jenny says, hello. I just got back from the cruise. Yay, and it was wonderful. And so there she is saying that. And right now I have to refresh. We're going to talk about subscribe in an upcoming episode. Stay tuned. But here we are. I can redact my own message. Bloop. Redacted. Refresh. Yes. What if I try to redact Jenny's message? What's going to happen? Redact. Error. Console. Rejected one fact of type. Yaka message redacted. If I take a look at the server, I'm getting some messages here. Oh, look, no authorization rules defined for type Yaka channel. I forgot to do that one. Anybody should be able to create a Yaka channel. So that will be my reminder to go ahead and add that authorization rule. And so the server isn't notified that, hey, somebody's trying to redact a message that doesn't belong to them. It's just simply 401 rejected, boom. In fact, if you take a look at this network, here's the save. Rejected one message. Here is the response. Where's the response? Yeah, status code 403. 403, forbidden. Because it's not a 401, I know who you are. 403, you can't do that. And that's all run by these authorization rules, and they are created by composing these different authorization functions. So the way that I typically do this is I have a whole bunch of authorization functions, one per file inside of the shared model over here, and then I compose them all together using .with. And that way, the server can just call that one function and bring them all together. So we got this nice composition thing going on. There's one last thing that I want to take a look at before we delete all this code and all this data and go back to not having any application, starting the day over again. If we were to log in to localhost, press the Yaka database. Here we are. I could do select star from public.fact, semicolon. And whoa, there's a whole bunch of stuff. Let's select a few things. So let's select fields. Okay. Here's my type. There are different fields. So we can see this is the data that's inside of each of those facts. Fields is kind of long, so let's not worry about that too much. Date learned from public fact. There we go. Now we've got a record of when it is that we learned about each of these facts. So this isn't the date the fact was created, necessarily. In fact, necessarily speaking, this is later than the date the fact was created. The fact was created on the client. The server only learned about it a few milliseconds later. So that's why it's called date learned. In fact, if you were to connect two different servers together, and facts are happening over here, facts are happening over there, they both might learn about the facts at different times and then try to share them with each other and say, oh yeah, I already know about that one. But they each have their own date learned time. So This is when I learned about all those things, like the message redacted and the Janaga user and the username when Jenny signed on, all that fun stuff. But who created these facts? Select star from public.signature. Now this one is going to be some really long columns, but this Janaga user with this hash, that fact was signed by this public key at this time, and here's the signature. So lots of crypto stuff going on here, but only 5 rows, only 5 signatures that happened in this table, and that's because before you set up authorization rules, there are no signatures. And that way we can go back in time, we can see when did we learn about different facts, and who was it that signed those facts, who created those facts and told the server about it. In the future, we'll have an audit method that will go through the authorization rules and check the signatures and see if there is a fact that is no longer that is signed by somebody who is no longer authorized to have signed that fact. So you might make your rules extremely loose by saying, "Hey, anybody, well, authorized channel." That's the one that I missed. So any channel. All right. Boom. And then you say, you know what? I really want to lock it down. I only want specific people to be able to create channels. So let me go ahead and switch that from any to type channel j.4, do some kind of query to figure out which users are authorized to create those channels. And then at that point, you will be able to run an audit and check the database to see, has anybody created a channel in the past that would no longer be able to do so had this rule been in place. And then at that point, you can make your decision. Should I relax the rule again? Should I change it to a different rule? Or should I really go back in there and remove those channels, or maybe add them to the list of people who should be authorized to create channels? Choice will be completely up to you. I just want to be able to give you the tools to authorize people, to keep track of who did what, and to audit those that history to make sure that everybody is still authorized as they should be. So that is authorization in Janaga, and Groundhog Day is coming to an end. And you know what that means? That means that we have to come back here and say goodbye. Let's connect to Postgres. Here we are. Connect to Postgres. Here we are in Postgres, and now we can drop database Yaka. Oh, all of that work is gone. Well, at least we still have the code. We do still have the code, don't we? rm-rf Yaka. Wait a minute. Where's all the code going? All the code's going away. Permission denied. Oh, I'm apparently not authorized to remove Yaka. Oh, I can't. That's funny. That's just funny. Do I have something else that's looking at it? Projects. Here's my projects folder. Wow! Here is. Wait a minute. Under Yucca. Oh, wait a minute. Under Yucca. Permission denied. Well, I don't know why permission is being denied me, but at least you can see the code is gone, which means Groundhog Day is over. And tomorrow we start brand new, trying to build yet another chat application. See you next Groundhog Day.